Welcome to this DevTV presentation on the AutoCAD.net API. This is session 6, covering the input point monitor. In this session, you'll learn about the input point monitor and see how it is used to provide feedback to the user. The input point monitor monitors the input mechanism in AutoCAD. This event gives your application a lot of control for dynamically interacting with the user. The input point monitor allows you to get real-time aperture data, such as the current cursor position and a list of all the entities that the aperture is currently hovering over. You can also get which of the mouse buttons were pressed, and you can tell which grip point is selected. You can also create temporary graphics on the fly and display tooltips depending on the condition that you specify. You add a point monitor using an event of the editor. The delegate of this event is a point monitor event handler. Here is a command that adds a point monitor. Notice that it's created in a similar way to other events, such as the database events that were created in Lab 3. The point monitor event args is passed into the point monitor event handler delegate. This parameter is what you need to use to append a tooltip to the cursor. The context property of the point monitor event args allows you to get the entities under the cursor with the getPickedEntities method. This method returns an array of full subentity path objects. These objects will have a collection of entities, and one thing you can do is get the object ID of these entities to open the entity to determine what the entity type is. To create temporary graphics, you use the draw method of the geometry property of drawContext. Notice that the draw method takes an entity as an argument. To draw entities at a consistent size, regardless of the current zoom value, you can use getNumPixels in unit square to determine the values to use. This method takes a point 3D object and returns a point 2D object. You use that point 2D object's x and y values to control the size of the entities that you pass into the draw method. Now let's see an example of creating a point monitor by going through the steps in Lab 6. Here you see our Lab 6 Word document. It describes how to go through this lab. We're going to be working on two different commands and two different procedures. One of the commands we're going to create, the other one already exists, and the same thing with the procedures. One of them already exists. One of the point monitors will do two things. It'll add a tooltip to the cursor. When you place the cursor over an entity, it'll display what that type of entity is. It's also going to highlight the entry in the palette by making the text for that entry bold. The other point monitor is going to add some temporary graphics at different locations along the line that you select. So you're going to need to run the add data command from Lab 4 to add the data to that line. And you can see, like the other labs, you can copy and paste these lab steps into a project that you have, or you can use the Visual Studio provided projects, and I'm going to do the labs that way. Here we are in Visual Studio. I have the Lab 6 project open. Here you can see the start of Lab 6, and step 1 is right here. You'll find this in this project after the Add Data to Node. The first thing we need to do in this lab is to use the command method attribute and add a command. The name of the command we'll use is add point monitor. Let's name the procedure start monitor. And we'll move the end sub after step 3. In step 2, we need to declare an editor, and so we can use that to add our event, our point monitor event. So let's go ahead and type in dim ed as editor, and that's going to be the editor property of the MDI active document. So application, document manager, MDI active document, editor. In step 3, we'll use the add handler statement to add the event. So add handler, and for the object we'll use the point monitor property of the editor. And then for the delegate, this is going to be a new point monitor event handler. And then we use the address of and the name of a procedure for the delegate that we'll create. We'll just call this my point monitor. Okay, let's go to step 4 where we create the procedure. We'll call it, has to be the same name that we used as the delegate, so it's my point monitor. So let's just use public sub. And this needs to have a couple of arguments, and they need to be by val. We'll call one sender, and that's just an object. And the other one is by val as well, and it's a point monitor event args. We'll just call this E. We need to put the in sub after step 27. This procedure is going to be called anytime the cursor moves. And so now let's go ahead and determine what that functionality is going to be by doing the rest of the steps inside of this procedure called myPointMonitor. In step 5, we declare an array of full subentity type path. I'll just call this full ent path. So that'll be a full subentity path array. And the way we can get that is from the context property of the point monitor event args that's passed in. It's called get picked entities. Here in step 6, let's just make sure that there is something under the aperture when the cursor is moving. We'll check that full ent path array and just make sure that its length is more than 0. So I'll just type in if full ent path length, and we need to put the end if after step 27. So now we know we've got some entities under the aperture when the cursor is moving around. So in step 7, we're going to start getting those entities, but we need to open those entities. So it's like we did in previous labs, we're going to use a transaction to do that. So let's go ahead and declare a variable called trans as transaction. And I'm just going to get that from the application and then document manager, MDI active document database, and the transaction manager, and then call it start transaction. So we'll have a transaction that we can use to open the entities. Let's use a try catch block. and move the catch and the in try down below 26 and 27. We'll put the catch there and then the in try after 27. Now let's get the first entity that is underneath the aperture as the cursor is moving around. So dim int as entity, and that's going to equal the object that we're going to open with the transaction. So we use getObject, and for the object ID we'll use the array, the full int path, the first full entity path in there, and then we'll use the getObjectIDs. So that'll be an object ID of the first entity that's underneath the cursor, and then let's open that for read. Now in step 10 we can add a tooltip, and we can make it more interesting than just a string by getting the type of entity. I'm going to use the point monitor event args and then the append tooltip text argument, and it just takes a string. So we'll say the entity is a, and then the int that we got in step 9, get type, and then toString. So that'll tell the user what the cursor is currently over, what kind of entity that it is. In step 11, let's make sure that the palette has been opened, that the palette command has been run, because we're going to be accessing that. If it doesn't exist, we'll just return. So we'll do if my palette is nothing, then return. And this should be good enough for the user. We don't need to tell them that they need to run the palette command because they haven't ran it, so they wouldn't expect to see anything in the palette. In step 12, they will have the palette open, and we want to let them know which entity cursor is over. So we'll go ahead and just change the font so it's bold or not. So let's make a couple of variables as systemdrawing.font. I'll just call this one font regular, and we'll make another one font bold to use as well. So this is as a system drawing font, and that equals a new font, and we'll just use the font type in a string here, Microsoft Sans serif, and the size we'll just use 8, and then drawing font style regular. I'm going to copy and paste this code. I could call this font bold now. We just need to change this to bold. And we'll just assign this to the text in the tree view, either a font regular or font bold, to make it regular font or bold looking. Before we work with the layout, we want to suspend the layout so we can make our changes. And to do that, we go to My Palette and then Tree View 1 and call Suspend Layout on it. So in the tree view, we have the nodes, and we want to go through each of them. So here in step 15, we want to use a for each statement, and we'll just call this for each node as forms.treenode. That's in My Palette, Tree View 1, Nodes, and we put the next statement below step 21. Then here in step 16, we use an if-else then statement and test the tag property of the node, see if it's equal to the object ID of the entity that we declared in step 9. This is the entity that was in the array that the cursor is hovering over. If, and then node tag is equal to the entity object ID, and we'll use toString, we'll put the end if after step 21. So if we get here, we know that the node is the one we want, and we want to make it bold. So let's just see if it's already bold. We'll type in if, and then not, font bold, equals node font. Then we want to make the font bold. Put the end if after step 19. And in 18, we'll type in node font equal to font bold. And let's make the node text equal to node text to update it. I see that I've missed a step now because I was supposed to put the else statement after 19, so let's go ahead and do that. And the end if was supposed to be after step 21. So let's go ahead and move that or fix that. So this is the other case where we want to make the text of the font in the node, we want to make it so it's not bold. So in step 20, do something similar. If not, font regular equals, and then node.node font. Then in step 21, we'll make it regular. So here we are in step 21, and we just type in node font, and we want to make that equal to font regular. So now in step 22, we recalculate the layout. We just need to use resume layout. We'll get to My Palette, and then Tree View 1, and resume layout. And 23, let's refresh the palette tree view. And then we'll call the update method on the tree view. If we get to here, all is okay, so let's go ahead and commit the transaction. That's trans.commit. And in step 26, we need to write the message of the exception. And so that's what we need to do here. And we needed to add a finally block. And I'm just going to move these instructions down to below the catch statement. So let's go ahead and write a message out with the exception text. You can use application then Document Manager, MDI Active Document Editor, and then write message. And we'll just use EX toString to put the exception text on the command line. Then in step 27, we need to make sure we dispose of the transaction in the finally block, so this will always get called. And now we can go ahead and test this part of the lab. This will add the add point monitor command, and we can run that in AutoCAD and test to see if our code is going to work properly. So let's go ahead and debug this. I'm going to debug and start debugging. Get an error, so let's go ahead and fix that. So I've misplaced a parentheses. Let's see if we can build that again. This time it ran okay, so let's start AutoCAD up and debug. Okay, so here we are in AutoCAD. I'm going to type in the netload command, load our DLL, run the line command, and type in add point monitor. Then when I hover over the line entity, we can see a tooltip, and it says the entity is an Autodesk.AutoCAD Database Services line. And the other thing we need to do is see the results of our command in the palette, so let's run the palette command. Run the DB events command. Let's add another line so we can see that in the palette. And see how the line is highlighted. It turns bold when I hover over it. I'll draw a circle, and it's also highlighting, but the code doesn't seem to be working quite right. I think there's a problem because both of these shouldn't be highlighting. You see over here in the palette, even though the cursor is hovering over the circle, the line in the palette is still bold, and so there's some kind of problem. So let's go fix that. So let's go back over to Visual Studio and stop debugging. And I think I know what the problem is. I believe I put an if statement in the wrong place. So this end if was supposed to go after step 19. I put it down below here. So this goes below step 19. So our else statement will be in a different location. Let's go ahead and run this again and see if that will solve that problem. Okay, AutoCAD started up again. Let's run the netload command first. And let's go ahead and run the add point monitor. And when we hover over the line, it's highlighted. Let's draw a circle. And now that's highlighted in the palette when we hover over it. And then the line is correct. So now we get this correct behavior. It's switching properly when we hover over these entities. Let's draw another entity just to show that it's working okay. So here's an ellipse. We hover over the ellipse and it highlights. Then we hover over the line and it gets bold, highlights, and then the circle. So the code is working okay now. So let's go ahead and go back and finish the other steps and add another point monitor and show the behavior where we create the temporary graphics. So debug and stop debugging. And then, so the next steps are in a command called new input. And you can see here that the code to add the input point monitor is just given to us. We've just did that in our previous steps. So we don't have to add a new command, and we don't have to add the point monitor. the function is called myInputPointMonitor, and we'll work on that. And here's step 28. We want to enable the AutoCAD input event mechanism to pick under the pick aperture. So we do that by calling the turn forced pick on. So ED, and then turn forced picked on. So dim get point options as prompt point options. That'll be a new prompt point options. And we'll just say pick a point. And let's get a prompt point result for step 30. Call it get point result. So we use the editor and then the get point, and we pass in our get point options. So if everything's okay, you could do something, but we're just trying to stop the function from running using get point so we can use the point monitor that we created in this command as well, because we're going to remove that event when we leave this command. So we use a get point so we can see the result of our input point monitor. So in step 31, let's use remove handler, and it's the point monitor of the editor, and the use address of, and then the name of the sub is my input monitor. We don't actually have to create my input monitor. We did that earlier. Same idea. We have the ByVal sender as object and E as point monitor event arc. So we have done that in the earlier steps in this lab. And we also use the full sub-entity path. So this code is the same. We just make sure that there's something under the aperture. Then we get a transaction created. We use a try-catch block. We get the entity. It's declared as a curve, and we open it for read. So you can see here how we got the object ID. We did that earlier. We make sure that it has an extension dictionary. We make sure that it's valid, and this is the code that we created with the extension dictionary. So we just are going to get the data from the dictionary, and we're going to use it to create our temporary graphics along the entity. We'll use a line. So we get the extension dictionary called extension dict, and then we get the object ID of the entry in that extension dictionary using the myData string. We create an X record, and we use the transaction getObject. And then we're in our step 32 for this lab, where we'll create the temporary graphics. So we need a for each loop, and we're going to go through the type values that are in that X record for each. So this is going to be a type value, and then you might remember what this is in my X record data. So this is similar to what we did in our previous example in lab 5, where we went through the X data and just printed that information in on the command line, or we added it to the palette. So let's move our next statement below step 45. And then see if the type value is a real. If my type val type code equals DXF code real, then we're going to locate some temporary graphics along the curve. So we'll put the indif after step 45. So here in 34, we want to get a point along the curve, so we can use get point at distance to do that. So let's declare a point 3D. And then we'll make that equal to the int get point at distance and get the value from type value. So that's my type value, and that would give us a point 3D object. In 35, we need to get some values to use for the temporary graphics, so we're going to use the get num pixels in units square, and so we'll use a point 2D that get num pixels in unit square will return. We'll just call this pixels as point 2D. Context, draw context, the viewport, and then the get num pixels in unit square. And then we need to pass in the point that we created in step 34. So now in step 36, let's get a double. We'll call it xdist. And we need to make that equal to 10 and divide that by the x property of the point 2D variable. So that's pixels.x. And we need to do the same kind of thing in step 37, but we're going to get y distance. And so I'm just going to copy this code and just call this dim y dist as double, and then that's pixels.y. So we're going to use these numeric values to control our temporary graphics and the size of them, so it'll appear to be the same size regardless of the zoom value that is created. And you'll see that when we run this code, that the graphics will appear to be the same. Declare a circle as a new circle. Then we use the point for the center. Then we can use the z-axis of the vector 3D for the normal. And then for the radius, we'll use the xdist that we've got from get num pixels in units square and dividing that by 10. So it's basically keeping a constant size for the radius. And then we need to use the draw method to display the circle. We'll use E, context, then draw context, geometry.draw, passing in our circle. So I need to change this, and then that's draw is what we want. So that'll draw the circle at the location along the line that we've got from our type value that was added. We want to add some other temporary graphics. In this case, it's going to be some text. New text. And then you want to set the defaults for the text. So we can just call set database defaults on that text entity. This would be settings such as the style that the text is going to use. So we need to control the position of the text, and we want to use the same point as the circle, so the center of the circle, but we need to offset it by the radius. And we use a position property to control the location. The text position is going to be equal to the point plus a new vector 3D. And that new vector 3D, we just pass in the distances that we've got earlier. So x dist and y distance. And then for z, we'll just use 0 for the location. Then step 43, we want to use the data from the X record for the text, so we can use the text string property of the DB text and make it equal to the value of the type value. Text.textString equals my type val value to string. Let's control the height of the text. We'll just make that equal to the ydist variable, that double. And then let's use the draw method to draw the text. It's e.context, draw context, and then geometry, draw. This time we'll pass in our text. And that is all the steps. Let's see if this part of the lab will work all right. So we're using the point monitor event args that's passed in quite a bit here to control the temporary entities, and we're getting data from the X record and using that to control the properties of the temporary entities. I'm going to go to debug and start debugging. Looks like we had some errors. Let's go ahead and fix that. And this is as new DB text. So let's try building this again. So go debug, start debugging. Here's AutoCAD. Let's run the netload command. Run a line command, and let's make the line longer than the entries in our X record data. So I'll just make this 120 units long. Then we'll do a zoom, an extents, so now we can see the entire line. And then I'm going to run the new input command and ask me to pick a point. And you don't see any temporary graphics yet. So what I forgot to do is run the command called add data. So we'll add the extension dictionary to the line. When we run new input, this time we see the data, but I see that it's not right. There should be 51 point something, and this is 100, not 1. So there is a problem in the code. So let's go ahead and fix that. So what has happened, if you look at our type value to string, I have a 0 in there, my mistake. Let's see if that will fix this. So let's start debugging again. Now here's AutoCAD, and let's load the DLL, Try the same steps again. The line, make it 120 units. Zoom extents. Let's add the data. And then run new input. Hover over the line now, the data is correct. So that was a bug in my code. And now I get 51.9 and 100. So that is the temporary graphics example that this lab does. Now let's just review the rest of it. So we can run the palette command. Add the events. And if we add the point monitor that we created, it highlights the particular line that we have. This one is not in the palette because it was added before we added the event. So let me just draw another line. And now it switches, the palette switches, so that's working correctly. And then we can add the data to this line. And then new input uses another point monitor to draw temporary graphics along that line. And notice now that you don't see the temporary graphics drawn at 100 because there's no point along that line at 100. When you go through these lab steps, you can explore a little bit, maybe change how the lab works. Thank you for watching this DevTV presentation, and good luck when you go through the steps in Lab 6. We'll continue this AutoCAD.NET API training in Session 7, where you'll see how to use jigs that will allow you to provide a drag image in the AutoCAD editor.